I'd like to go through what you guys learned during your investigation, how this turns into formulas, which you're going to use a lot when you are doing arithmetic sequence and series problems. First of all, I'd like to tell you the difference between a sequence and a series. A sequence is like a list of numbers. For example, 5, 7, 9, 11. Okay, that is a sequence. What is a series? A series is when you want to take all those numbers, you want to add them together and find out what their sum is. Okay, so this is a sequence and this is a series. Okay, all right. Now let's look at one of the examples from the investigation. You had a piece of paper shaped kind of like this, and you measured the left side, let's say it was 5, and you measured the right side, we don't know what it is yet, okay? And you noticed that all the step sizes were 2, okay? Now, can we find the size of the right side by being clever instead of just counting? Well, we could look at the step sizes and we see that it's rising by 2. Okay, so what if we just counted how many steps there are, and then we use that to figure out what this number is. So we start with 5, and then we're going to add 2, and 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 then we're going to get this number. Oh man, but if we add 2 so many times, isn't that just multiplying by 2? So let's figure out how many times we're going to multiply by 2, and then we'll just add a multiple of 2. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. So we're adding 2 8 times. So what if we, instead of adding 2 8 times, what if we add 8 times 2? Okay, so we're going to get this number by doing 5 plus 8 times 2. Okay, so that would be 5 plus 16 would be 21. So we were kind of clever about it. We didn't like go through and count all the blocks on this side. We counted just the left side, and then we noticed that each step was 2. Okay, but then we did go through and we counted every single step to see how many steps there are, right? Could we be more clever than that? Well, what if we looked at the width? The width of this, like on your investigation, is 9. Okay? Now, is it a coincidence that the width is 9 and the number of steps was 8? Actually, it's not. The number of steps is always one less than the width. The reason why it's not exactly the width is because the first step there is no increase, right? It's just that height and that's it. So there's no plus 2 for the first step. That's why there's 8 step increases instead of 9. Okay? So if we wanted to make a formula to get this 21, we would say, oh, I would take the first step or the first height, and then I would add 9 minus 1 steps, and each step is 2. Okay? And that's how I would get 21. And actually, that is what the formula looks like. The formula says, oh, if you want to find the nth step, okay, in our case, we're looking for the ninth step, but if you're looking for the nth step, you would take the first height, and you would add n minus 1 times the step size, okay? So instead of 2, we're just going to put a d there. Instead of 9, we're going to put an n, okay? And instead of 5, we're going to put u1. Okay, so u1 is like the first height, and un is the nth height. Okay, so in the case of 21 equals 5 plus 9 1 minus 1 times 2, what we did was we were looking for u9, and so we took u1 and we added 9 minus 1, and then with the step size, which is 2. Okay, so that you can see how the equation un equals u1 plus n minus 1 times d, which is on your formula sheet, is very similar to what you did in your investigation if you wanted to calculate the right side without actually counting the right side. You would count the left side, and then you would count how many steps there are, and then you would multiply times how many steps. Okay? Now let's go to the process where we took our funny shape and we made a strategic cut. about there. And after we made the cut, we took this piece and we turned it upside down, and then we fit it exactly there. And what that gave us was a rectangle that is a lot easier to figure out how many squares there are than that funny looking shape. So, and remember that the way you figured out the dimension of this rectangle is the width is also 9, but the height, you actually took the average between the small height and the large height. Okay? And the way you found the average was you took the first term and you took the last term, okay? You took u1 and u9 and you divided it, you added them together and divided by 2. Okay? And then how do you find the area of this rectangle? Well, you just multiply this times 9. Okay? And remember, 9 is just n. It's the n, it's n wide. Okay? So the formula we used, for example, was 9 times, and then remember the left side was 5 and the right side was 21, so it's 5 plus 21 divided by 2. Okay, that's the formula we use to figure out the area of this rectangle. But if you want to generalize, 9 is actually n, 5 is u1, 21 is u9, okay, or actually un, right, because we want to be general, un, and we divide the whole thing by 2, okay? And this is the formula to find the sum of all the terms. So like, remember I said a series is the sum of all the terms? Well, how do you find the sum of all the terms in a clever way? Well, you do what you did on the investigation. You cut off this part here, and then you turn it upside down and you fit it in. You make a rectangle, and then you multiply the height of the rectangle, which happens to be the average of the left and the right side, times the width. And so the formula actually looks like that in the general case. Now what if you didn't know the right side? What if you didn't know u of n? What could you do then? Well, actually you have a formula that tells you un if you know the left side and the step size. So you could make a new formula, and your new formula would have n over 2, and then inside you have u1, and then instead of putting un, you're just going to put an expression which is the same as un, which is u1 plus n minus 1 times d, which is the formula we got above. Okay, so to find the series sum, you could either do with this equation in case you don't know un, and you use this equation if you do know un. Okay, so those are the three formulas you're going to use throughout the problem sets, and those are given to you on the formula sheet. All you need to know is when to use which one and how to substitute in.